So welcome to this next session of the DNVGL conference, where we'll be talking about wind power and how wind power is a driver for offshore grids. Let me first start introducing our distinguished panelists. Lorenz Müller is Senior Executive and Head of Regulatory Affairs at 50 Hertz Transmission. Piotr Repka is expert at PSE Innowacja, a doctor company of Polish TSO PSE. And then Cornelis Pletz, who is Principal Consultant and Expert on Transmission and Distribution Technology at the DNVGL. To get started, let me set the scene. GWEC talks about an offshore wind market to grow from the current 29 gigawatts up to the 230 gigawatt by 2030. If you look at the US, from almost zero today, the market could go up to 30 gigawatt by 2035, New York only having 9 gigawatt. From a European perspective, the European Commission in its offshore strategy document talks about 300 gigawatt by 2050. If you look at the same time horizon, 2050, the Ocean Renewable Energy Coalition talks about 1,400 gigawatt to be installed by 2050. So no doubt the opportunity is huge. But as we embark on this journey, we witness how in 2020, how last year, grid became central in the conversation and one of the key issues to be addressed. Governments, research and academia, project developer, TSOs, all stakeholders are eager to understand and address a number of questions like, what does this huge amount of power means for the grids? How to connect and integrate offshore wind to the onshore grid? And what are the opportunities that this offshore wind boom will bring to the power system? So these are the topics we will be discussing now in this panel, and I encourage you, the audience, to log in your questions, to pose your questions in the system. We'll be answering them at the end of this session. So let me get started with you, Lorenz. What is 50 years experience so far integrating offshore wind from the Baltics?
Well, thanks for the question, and hello to all of you. So 50 Hertz already has a significant track record in integrating offshore wind power into the onshore grid. We already successfully delivered a number of wind farm connections, starting with Baltic 1 back in 2011, up to now where we recently finalized the combined grid solution, which is the world's first hybrid interconnector. So by connecting the grids and markets of Denmark and Germany via an interconnector that integrates Danish and German wind farms, we contribute to the target of climate neutrality and deliver the first step into a future offshore grid in the Baltic Sea. Basically, we've set the mission to cover 100% of the electricity consumption within our control area by renewable energy sources by 2032. And thus to contribute to the European Green Deal. And we believe that the expansion of offshore wind energy is the key factor to realize this ambition. We, of course, intend to harvest the full potential of offshore wind and to carry this out in a coordinated and efficient way. So instead of only focusing on local and radial wind farm connections, we need to combine this with common international initiatives by establishing hybrid assets with interconnection capabilities and thus creating offshore hubs and potentially a meshed offshore grid in the future. Together with our Danish colleagues of Energinet, we recently signed a letter of intent on the preparation of the Bornholm Energy Island, which will be the next major step and the first real offshore hub.
Thank you very much, Lorenz. Moving on to you, Piotr. So how does the situation look like from a Polish perspective? So what are your plans in Poland to integrate offshore wind?
Yeah, thank you for the question. The situation in Polish is very interesting now. In the first step, I want to emphasize on the fact that all options that I'm going to express are my own, not of the Polish TSO. Yeah, I'm also work at university and I'm interested at technical development of power system. I agree that integration of offshore wind farm into the transmission grid is a huge challenge for Polish TSO. I think specific Polish challenges are the same like in any other country which want to connect or integrate a lot of offshore wind farm with PS. But what is the huge challenge for Polish? Because we are forcing the very big development level of offshore wind farms. In the first phase, the level of 6 gigawatts. In the second phase, we will increase it approximately to 10 gigawatts, but in the third phase, even can up to 30 gigawatts. From this perspective, I can distinguish three different scenarios to fully integrate offshore wind farms with power systems. The first scenario, I think about HVDC cables to export power from offshore wind farms to coast. Yeah, you can use this case when offshore wind farms are close to coast and when you have enough transmission capacity in existing transmission network to export power from the coast to deep inland. This solution is the best in the first steps when you start integrated offshore wind farm with power systems. In the second scenario, I think about HVDC links with traditional point-to-point structure. You can use this case when offshore wind farms are far from coast and when you don't have enough transmission capacity to export power by already existing transmission networks. In this solution, we should build HVDC links directly from offshore wind farms, which is located deeply in sea, to deeply mainland, where you have a big demand. But I think that first scenario will be the best scenario for us, especially for the future, because I think about HVDC power corridor, but HVDC power corridor with using multi-terminal technology. When you have a lot of offshore wind farms, you should build, for example, one or two HVDC corridor. For example, one on the left side and second on the right side. And finally, you can even connect both ends of this system together. In this method, you will finally achieve mesh grid, yes? Very good regulation. Mesh grid is a very good regulation tool. The third scenario is more complex, but it will give us a best solution. And you should notice that in the first scenario, you put DC grid on AC grid, and you will get hybrid AC-DC grid. Widespread hybrid AC-DC grid is a flagship in research, development, and innovation roadmap published in NSOE. And generally, we should go in this direct.
Thank you very much, Piotr. Going to you, Cornelis. I think both Piotr and Lawrence depict quite well where we're heading to. But what is your view on what is needed to reach our 2050 goals?
Yeah, so both Piotr and Lawrence already mentioned some of the items that I want to discuss here about. First of all, in order to meet the 2030 and 2050 goals, one of the things that really needs to happen is that we need to increase the build-out rate at which we actually build offshore wind. Because at current rates, we're probably not going to hit those targets. And this also means that we will have to increase the rate at which we build out offshore grid infrastructure to build all of these offshore wind farms. And not only a step change in the build-out rate, but also a paradigm change in how we build grids, especially when it comes to HVDC. So we need to move from the traditional point-to-point model, which we have now, in which HVDC links are really built for the specific purpose of interconnecting individual wind farms and are optimized for that purpose. They only serve one purpose, so only the export of offshore wind or only the interconnection of two different countries that typically have only one owner, which could be a joint venture, but and are often supplied by just one vendor, to a model where the HVDC grid infrastructure is indeed a multi-terminal setting, so no longer just point-to-point, that carries a multinational aspect of it, so it must be cross-border. It should also be possible to serve more than just one purpose. So not just the export of offshore wind, but also the interconnection of countries at the same time. This is, for example, the hybrid asset that Lawrence referred to earlier with Kriegers Flak. And it should be multi-actor. Why should there be only one party involved? For example, the TSO model that we have now in Europe, you could also split different responsibilities, for example, for owning and operating these grids. And lastly, which is also very important, it should be multi-vendor, because if we go to a Europe-wide grid, we want to be able to buy this from different sources. And that really requires a change in the way that we build it. We need to think ahead. What do we need in the future? We need to accept that we cannot make a blueprint for the grid that we want to build in 2050. So this grid will have to develop incrementally. So we need to come up with a paradigm of building HVDC grid infrastructure that is flexible, that can be extended based on what the transmission need at that time tells us to do. And this really means that we need to build compatible links that are compatible on a range of different levels, starting from a political level. Of course, we need to align where we want to go with countries, agree on how to share the costs and the benefits of this type of infrastructure. We need to align the regulatory frameworks behind building these grids, the market models that are involved, how to plan and permit for these grids. Of course, we need to ensure that we plan the system also in ways that are compatible, preferably on a European level. And then, of course, from a technical perspective, we have to make sure these grids actually work together. To start, they must have the same voltage level. If we build a grid in Poland and we build a grid in Sweden and they have different voltage levels and they meet in the middle of the Baltic Sea, it will be difficult or at least costly to connect those into one. And this will require a large extent of coordination between all the different stakeholders that are involved in building such a grid. And that is really where I think a step change will be needed in the future in getting all these parties together in an even more strong form of coordination than what is happening today.
Thank you very much, Cornelis. You guys put us straight on, but let's go back step by step. We have a good vision where we are heading to, but I would like maybe to think on the journey. So what are the milestones we need to get there? What are the next steps? What are maybe the no regret decisions we need to take now to make this vision happen? Maybe we can start with you, Lawrence.
Yeah, well, several things have already been addressed by Cornelis and Piotr as well. And I also mentioned in my first answer that, of course, we need to urgently start doing that or continue doing that. We need to harvest the full potential we see. Of course, we need to develop the standards and technologies. There is no common standards. There is no multi-terminal solution in place already for DC technology, DC assets. So that needs to be developed. Fortunately, there are already ongoing initiatives where TSOs and vendors also meet in order to develop such standards and multi-terminal and multi-vendor solutions. And that's really required to realize that. And Cornelis also mentioned the regulatory and legal framework which needs to be put in place, because that's also very important that the right incentives are set to actually build and create that grid and to realize the offshore potential we see in the northern seas, in the Baltic Sea, also in the North Sea, of course. And to agree on joint and coordinated planning and system development is also a key factor for successful development here. So first steps are taken. We signed, or 2 MOUs have been signed. So one by the neighboring countries of the Baltic Sea recently, and on that basis, the TSOs in the Baltic region also signed an MOU to actually go into that direction, to do a common planning here, and to agree on standards and the way forward to realize such a grid.
Thank you very much. From a Polish perspective, Piotr, what are those next steps you see?
Yeah, uh, I fully agree with my colleagues. And if we want fulfill integration offshore wind farm with power systems, yeah, we have to build a special DC grid, for example, hybrid AC-DC grid. And I think if we want to do it properly, right now we have to develop DC breakers because technology, sorry, right now we have to develop DC breakers because technology readiness level is low. In line with information of the NCOE website, TRL for HVDC for high voltage DC breakers is 6 and TRL for high voltage extra high voltage DC breakers is only 4 out of 9. DC breakers are one of the most important element in HVDC mesh grid, yeah, because it guarantees stable operation during the fault. Secondly, we need immediately what we need immediately is very good standardized inverter model for transient analysis. Now we have a good models, but each specialized software needs its own models. From the perspective of TSO, when I want to make analysis about interaction between different offshore wind farms or between offshore wind farms and power system, I can get different model from different investors or vendors, yes, and I will be having a big problems to connect them. And many times, even if I ask producers about these models, I will have the same problems. Many producers give you the good models, but they use only their types of software which are supported by him. This is a reason why we need to standardized models. And if you want to learn this mesh grid, how it should operation, we should get a good standardized models. Thank you.
Thank you very much. Cornelis, your view on this.
Yeah, I think there are, of course, many different things that can be done, but I'll just highlight a few. First of all, I'd like to challenge really the notion that the technology readiness level of DC circuit breaker is low. I think from a technology perspective, it has been shown that you can build meshed multi-terminal, multi-vendor HVDC grids. In China, several of those grids have been built and are in operation. But what unites all of these grids is that they've been built by one single TSO within one regulatory framework, which simplifies building these kind of systems. And that brings me to the point that Lawrence made, that progress is being made in political collaboration and agreement in Europe. You mentioned 2 of those bilateral agreements already. I think there's a third one, making a sort of triangle of bilateral agreements between Denmark, the Netherlands, and Germany. That still doesn't help if all of these agreements end up being different. So I think a very important next step would be actually for those countries to go and sit together and realize they're making agreements with all of each other and make one single multilateral agreement. And once that one single multilateral agreement is out of the way, and now that Brexit is out of the way, maybe we can start looking to the future also with the UK again to see how we can get them a place at the table in such multilateral agreements. That's on the collaboration front. When it comes to more technical matters, of course, we've already talked about standardizing how to do tests, standardizing parameters between different grids. But one very important thing is also to standardize the behavior, which is typically described in a grid code. And currently, such a grid code doesn't exist for HVDC grids. and starting the development of such a grid code. And it has to be recognized that this is not a one-off step that you can take. It's something that evolves as experience of technology is gained. But starting the development of such an HVDC grid code and system operation guidelines for HVDC systems is something that we should really start with today. And I believe that the consortium of TSOs and vendors that Lawrence referred to is going to make a start with that. So that is good news.
Thank you very much, and thank you for highlighting those next steps. I think it's important we understand what we have to do concrete. But if you allow me, and very quickly, because time is as usual eating us, but very quickly, if you talk about some milestones, no, because it will help also the audience to understand and have a sense of urgency of doing things, no. What are the in a time frame? What are the next milestone? When do we need the next hybrid? When do you foresee a mesh grid? What do you foresee these next steps we've mentioned here? Maybe very quickly, put your best guess, Lawrence, if I can start with you.
I think Cornelis already said that this will evolve in a stepwise approach or way. So I believe the first step, of course, and we already see that. Of course, there are still many potentials in the coastal areas in several countries that still need to be harvested. But the first step are, of course, the radial connections. We have already realized quite a number of them, and we will continue doing so. The next step then will be probably what we also initiated with the combined grid solution, the hybrid and transnational solutions. So to really start interconnecting systems and markets via the offshore wind farms. And then that will be probably around 2030, 2035 to 2040. And then the integrated hubs and the meshed offshore grid will then be the development onwards, the final step from 2040 onwards. So as I said, we are currently developing the Bornholm Energy Island, which will be the first hub to be realized by 2030. So that's of course a very important step. We are preparing that together with the colleagues of Energinet, and I think several other hubs will then need to be developed as well. There will be one in the North Sea, as far as I know, or shall be one in the North Sea, and that will be then the next step to come to such a kind of meshed grid in the long run.
Thank you very much, Lawrence. Bornholm 2030, mesh grids around 2040. Piotr, from a Polish perspective, what do you see? You talk about three phases, some dates, some years to get a bit more sense of the reality here.
Yeah, what should be important for us in the next steps? Yeah, I think that in the next steps will be very important for us to set a rules for interoperabilities of HVDC links. Yeah, interoperabilities of built DC big DC systems. We will have to implement an interoperability rules to each elements of these networks, like we do it now in AC networks. Only interoperability rules will give you a easier and faster possibility to develop this grid. You will be I think that this grid should be developed permanently, but step by step. Yeah, you can attaching a new part of the grid to the old part of the grid. If you want to do this, you need interoperability rules. These rules, this is a huge challenge for us, but we have to start thinking seriously about it. I know that it can be a very hard, but I believe that we can do this like we did it in the AC networks. Today, when you want to connect to AC grid, you have standards, you have a specialized requirements, and you can do this. You can connect each elements from different vendors, different producers, and it will be operate together perfectly. I think that we should do the same in the DC grid.
Thank you very much. Cornelis, your view from your perspective, and maybe we can try to address also what do we need to do concrete to get to the mesh grids and demonstrate technologies. Your views on all this.
Yeah, I think you touch a key point there, which is the point of demonstration of pilot projects. Projects that are the first in their kind in demonstrating that legal or technical or regulatory challenges can be overcome. Of course, the Kriegers Flak project was an example in that that you can build hybrid assets also from a regulatory point of view. And I hope that in the near future, the next hybrid projects like maybe the Wind Connector or the Nautilus Link will actually also be able to overcome those regulatory difficulties and come into operation. From a technical perspective, we need a pilot project that shows that this multi-vendor interoperability is possible, that Piotr looked at, but also that the technology that we need to build this meshed HVDC grid can be brought to a level that it is seen as reliable and effective enough. And this will require a full-scale pilot of this new HVDC technology, so HVDC circuit breakers, an HVDC grid protection system, and a multi-terminal, multi-vendor compatible grid control system. The Bornholm Island concept that Lawrence referred to is an ideal situation where something like that could be piloted to show that using multi-terminal HVDC grid technology is technically possible and that it does bring a benefit to the European consumer by reducing the overall lifetime costs.
But and to get to the end, we focus on the offshore grid, on the offshore infrastructure. I would like to close here now, asking you, the panelists, anything outside of this, of the offshore grid, that we need to talk and need to consider. Any thoughts around that? Lawrence, maybe starting with you again.
Yeah, I think we already tackled quite a number of important challenges we need to overcome, and in order to be able to realize that perspective. Of course, others need to be tackled as well. We discussed DC technologies, multi-vendor solutions, but also, of course, other things like floating foundations and solutions will be relevant if we go further offshore and really want to realize the potential there. Environmental issues always need to be taken into consideration. Public acceptance. Of course, we need to consider the socioeconomic optimum and make it beneficial for the customer in the end. Sector coupling will play a role as well. So I think, personally at least, I believe that hydrogen will also play some role there, even though I believe that electrolyzers will be located probably more on land than offshore. But however, it needs to be integrated in the planning. So all these things and the already mentioned regulatory and market requirements and settings need to be prepared in order to make that future happen.
Thank you very much for opening the picture. Piotr, from your perspective, what else do we need to look at?
Yeah, I have noticed one more important limitation to fully integrate offshore wind farm with power systems, to fully develop DC grid. I think that we need increase operators' awareness of this possibility of using HVDC systems to support system operation. Why? Currently, many HVDC links don't use this full potential. Yet TSO, they don't need it because they have a lot of regulatory possibilities for example, in classical sources. In the future, these types of regulation will be much more limited. HVDC can be used to support the management of power systems operation in steady states and also in dynamic states. But in practice, they are very difficult to use it. Today, network cards give us a huge technical ability, but appropriate set of these functions is still on the side of TSO. And in many cases, we don't know how to set this function because system structure and changing is not system structure always changing. Yeah, it's not fixed structure. And I want to emphasize that in practice, in power system, we have much more connection and conditions than in academics consideration. And this is, I think, we should build new types of knowledge, new quality of knowledge to how we can fully integrate possibilities of HVDC links to operate power systems. Thank you.
Thank you very much, Piotr. And ending with Cornelis, a number of topics I've already mentioned, maybe not to repeat. If you look towards the onshore grid, anything you want to mention there, Cornelis?
That was going to be exactly my point. Don't forget the onshore grid. So we're going to build hundreds of gigawatts of offshore wind in the North Sea. They will have to be transported to the end consumer somehow. And also when there's no wind, we still need some source of energy that needs to be balanced or coordinated somehow with the offshore wind that we build out. So from a system planning perspective, you should really carry out as much as possible a whole systems approach where you look at the onshore and the offshore system with all the different energy sources that are available in there and their characteristics, the different types of storage that we can apply or power to gas types of facilities, and of course options for flexibility and advanced control that Piotr was referring to, how that can help us to defer investments or use the grid more optimally. Because don't forget, in addition to having to build out and increase the capacity of the onshore grid, we also have to replace a lot of the onshore grid equipment, which is getting most of it quite old already.
Thank you very much. I think with this we have a nice roundup, and again, thank you for your contribution to this conversation. Some key points we discussed. I think we can say that this vision I was referring at the beginning, if you just take about Europe, 300 gigawatt, we see a pathway. You guys see a pathway, and you've been very specific to get there. We learn how these point-to-point connections are where we are today. They work, but we need to think next. We need to talk about this hybrid transmission systems as the next step as we move towards mesh grids. And mesh grids is then our next target, and needs to start working on that. Building blocks are there, they're existing. We need this demonstrator, as you mentioned, but we need also this international collaboration. We need this regulatory framework around that to make it possible. And as we said at the end, we need to consider other things, these onshore grids, the big elephant in the room that we should not forget, and look at the new challenges like floating or sector coupling, as you mentioned. So with this, I would like to now give the floor to our audience with the questions that have been logged in the system, and we'll be answering to those questions as we go. So I think we are live now on the Q&A session. And with this, I would like to thank our panelists and encourage the audience to keep logging your questions in the Q&A part of our screen. Let's move on immediately then with the first question, as all our panelists are logging in. Let's put our first question that comes from Christian, who talks about and asks around ENSOE vision and description of the system of the systems, and a European network centrally operated by ENSOE with regionally coordinated centers. And the question is, how open are the TSOs and countries to back up these ideas? I don't see Lawrence yet on the picture, but maybe Cornelis, you want to take a first take at this question?
Yeah, sure. And obviously, I cannot speak for TSO, and indeed, I think it's best to ask a TSO to comment on this. But what I do remember is when the concept of the regional coordination centers were introduced a few years ago, they weren't met with a lot of enthusiasm from TSOs or indeed the different European countries. And even though I think from a technical perspective, this is probably a very nice and a very good idea, it is important to remember that in Europe we do have nation states that do need to have some form or at least some feeling of sovereignty about their own energy plans. And I think that that is what we should always aim for in setting up a system, whether it is from a technical perspective or from a regulatory perspective, to try and find the minimum set of aspects that need to be aligned or coordinated on a supranational level, whilst respecting as much as possible that individual states can still steer their own energy future.
Thank you, Cornelis. Lawrence, you're with us. Can you hear me well?
I can now hear you. Yeah, I had some
Very
difficulties, but now it works.
good. So the question was around the view of TSOs on creating the system of the system, knowing the centrally regulated. Do you want to take a chance at these questions?
You mean the TSO approach to develop the offshore system of the future? Yeah.
And the system of a system, so overall coordination, central coordination of a system.
Yeah, of course, that's a very important issue and task for the TSOs. And there are also already ongoing initiatives to tackle that. Of course, there are initiatives to come to let's say, coherent planning of the system. Of course, on NSOE level, we are tackling that topic, but also on, let's say, a smaller scale in the different regions. I mentioned in the presentation, we just heard that in the Baltic region, for instance, there is an MOU signed or has been signed that starts the initiatives in that direction, that we really come to coherent planning, that we make up our minds on system operation and all these things. So there are ongoing things, and we also tackled the question of how to do that, how to take the onshore system, the onshore grid into consideration when developing the offshore system, so that this is done in a coherent and optimal way.
Thank you very much, Lawrence. Move to the second question, and Piotr, I would like to have your first take on this one and see how other want to answer. So the question is: can the European Network Code requirements for generators (RRG) be seen as a step forward towards the development of an EU offshore grid, or there is still room for improvement in the regulatory framework aspect? So your view on the regulatory framework to get this happening?
Yeah. Now we have HVDC networks. Sorry. Now we have codex, RFG. We have a codex and we have a lot of rules. These rules are quite good, but we're thinking about developing these rules, especially in the offshore direct. Yeah, for example, we're thinking about more the rules of HVDC, because many times now you mention about RFG network codes, but for offshore grid, it's very important HVDC network code. There will be a rule, especially for offshore grid, when we will connect by DC HVDC links. And generally, when was prepared network code, we don't think about so developed offshore grid. Yeah, today we know about it, and in my opinion, European Union prepare modification uh, in a network code. Special modification, we can be considerate this aspect developed of offshore grid.
Thank you, Piotr. Cornelis, do you want to add something from a regulatory standpoint, where you see areas that we need to keep working on beyond what we have today?
No, I fully agree with what Piotr mentioned, and what I would like to add to the answer is that I mean, yes, the European Network Code requirements for regulators is of course a good first step to start to use in the development of these network codes for an HVDC grid. And we should not throw away anything that's good that we already have, but build on it and make sure that we use the characteristics and the functional behavior that is described in there to build the network codes that we need for an offshore HVDC grid to make sure that the two are compatible.
Thank you. Lawrence, this question, you have already kind of answered to it, no? But I think it's important to talk about the political sensitiveness, of the development. So the question goes for, if multi-terminal, multi-vendor, and multi-country models are the targets, how does this interact in a world where there are sanctions and leverage against countries? How easy is for this model to work in the geopolitical world?
Yeah, well, I think first thing is that, of course, there is a common political will to develop something in that direction. And of course, there are still hurdles to overcome because there are still many differences in the regulatory and political frameworks. There is a common European goal to develop offshore wind in order to reach the climate goals. And that means that in the offshore field, we need to dramatically increase the generation to harvest the potentials. We're talking about several hundreds gigawatts here by 2050. To make this happen, of course, we need a common framework and let's say we need to pull the same on the same rope in the same direction to make this happen. There are still things which I believe need to be addressed. For instance, still the question who pays for investments, how can we integrate the electricity into the markets, so who can actually make use of the offshore generation capacity, how can we integrate that into the markets, what happens then with market prices and so on and so forth. All these things need to be considered and solved, and that cannot be done nationally, but supranationally. The different countries and governments, of course, need to work in the same direction here. There are good signals, good initiatives, but that's not the end of the story, of course.
Cornelis, Piotr, anything you want to add on these questions?
Well, what I would like to add is, I mean, definitely this international aspect doesn't make things easier, but it's a nice challenge. And I think within Europe, this is actually a chance to bring Europe closer together, to further integrate the European idea and the countries around Europe. But also outside Europe, you can see that the energy transition is driving countries to talk to each other. A nice example is an interconnector which is currently in development or in planning between China and Korea, and potentially an extension to Japan. Now, these are maybe countries that you wouldn't have thought would be talking about energy cooperation in this sense, but they are. So I think that building transmission links and building these grids can play a big role also in bringing countries together.
Thank you very much. Piotr, your view from a Polish perspective, do you see Poland be connected then to Denmark, Germany soon through these offshore grids?
I think that build the very large power corridors, this is a good idea, and this will be it get you more stability, yeah, especially when you lose a typical regulation generation. Yes, and for example, you can achieve more stable and more regulation in power system operator. Okay.
Thank you. And I think we're getting to the end, and I would like to put this last question, which I think is extremely important. So going back to energy islands that Denmark has introduced and the sector coupling point, what is your view on this approach, and how do you think in the long run of energy islands to be the energy hubs or offshore mesh grids? So I think here, spot on. No, Lawrence, can we start with you?
Of course. Well, I believe that's a very important step to develop such hubs, such energy islands, or whatever you call them. As I said, I think first thing was the first step was to start, and still is, to start with the rail connections. Then the second step is to go into hybrid assets to combine interconnectors and grid connections, offshore grid connections. And then the hubs are the next logical step. So to have an area where there is wind production, and this area is linked to not only two but several countries to make it a real hub. And then the final, so to say, step is to connect even these hubs and come to a meshed grid. And that is, of course, a big challenge. And it will take several years, maybe decades, until we reach that goal. But that's probably the final target, to achieve such a grid, such a system, in order to use the generation in all surrounding countries and all over Europe, if it's socioeconomically reasonable.
And Cornelis, your take, and maybe bringing the Power-to-X dimension to is as some of those projects considering hydrogen production on the island.
Yeah. So I would also like to echo Lawrence's comments here that I see the hubs really as nodes in a future meshed offshore grid. And the aspect that it is an island is simply something that will help to bring the cost down when you're bringing really large-scale, very remote offshore wind farms online. That is, however, not enough to really integrate the generated offshore wind power into the onshore AC grid. And there are two aspects to consider there. One is, of course, the adequacy. How do we make sure we have energy when there's no wind? And the second one is the capacity of the onshore grid. How do we bring the energy from the wind farms from the point where it lands on the beach to the consumers further inland? And in both those aspects, I think power to gas or sector coupling, so it could also be power to gas and heat, for example, can play a big role. Especially when it comes to energy storage, of course, but also potentially in making sure that we don't have to electrify all of our demand. For example, processes where very extreme heat is required can maybe better be done with hydrogen, so you don't have to get this from the grid and invest in the onshore grid to make this happen. And for those reasons, I actually believe personally that the most likely location for power to gas facilities is onshore and not actually on the island. But of course, any decision in this would have to be based on really a full lifetime analysis of the different costs associated with it, but very much also the different benefits.
Thank you very much, Cornelis. With this, I would like to conclude the session. So hopefully, audience got the feeling that ambition is huge, but solutions are there and things are starting to move already. So thank you very much to the panelists for your insightful views. And with this, I would like to hand over to Gunnar Heyman for the expert session. Thank you very much.
And colleagues, thank you very much for your great, lively panel discussion. My name is Gunnar Heyman. I'm the Service Area Leader Energy Advisory of BNEGL. I'm 30 years with the company. In my role, I'm responsible for the services and the innovation portfolio in the service area Energy Advisory. And as moderator, it's a great pleasure for me to introduce my colleague and expert for the session, Dr. Cornelis Blatt, briefly. Cornelis, the colleagues in the audience might have met you during the conference today, or on other occasions. Cornelis has been the technical coordinator of the European Energy Project Promotion for the realization of meshed offshore HVDC networks. So he was the leader of the so-called Work Package 5, in which full power tests for HVDC circuit breakers were realized. He's involved in many offshore projects and also power failure investigation. He got his PhD on fault response of inverter-based distributed generation at Imperial College in the UK in 2011 and has been with DNVGL since that time. So for logistics of our meter expert session, we've got another 20 to 25 minutes. Please add your questions or remarks on the topic of grid integration, transmission grid specific solutions in the chat box. Some questions in the discussion in a minute will be maybe a kind of repetition, but we want to go a little bit deeper into the topic. And just for setting the scene and get started with our session, Keith, I would like to raise the first question. This is more about the where in this whole topic. So what will be the investment focus areas in offshore wind and HVDC in coming 10 years? Can you please elaborate on maybe investment volumes, capacity additions, where it is planned from a regional perspective?
Yeah, sure. I mean, we of course we already heard a few numbers earlier from Alfredo. He referred to the European targets for offshore wind. We currently have about 20 gigawatts of offshore wind installed, about 7 gigawatts in the UK, 5 in Germany, and yeah, following are Denmark, the Netherlands, and Belgium. And this is supposed to go up to 70 to 80 gigawatts by 2030. Big additions, of course, will come from the Danish plants, who are planning the 2 energy islands, Bornholm and an artificial island in the North Sea, which will total up to 5 gigawatts. But also Germany is supposed to make significant additions to their offshore wind capacity, up to about 17 gigawatts by 2030. Now, if we look a little bit further afield, for example, in the US, where right now there's virtually no offshore wind capacity, they have planned up to 20 to 22 gigawatts by 2030. And of course, yesterday there was the message that Biden signed to double this target by 2030. So that's definitely a very ambitious move. On the other side of the world, in Asia, there's also a lot of development going on in the field of offshore wind. So what is probably well known to us is that in Taiwan, there is already installed offshore wind generation. They have a target to go up to 15 gigawatts by 2030. But we should, of course, never forget what's happening in China, where they are planning to go from only a handful of gigawatts now to over 50 gigawatts by 2030. So they will also make a huge catch up by them. And yeah, how much this really costs, I don't really know how much a wind farm costs, to be honest. But what we estimated for the costs of the transmission infrastructure to connect all of this offshore wind in the promotion project is roughly 1 billion euros per gigawatt of offshore wind generation. Now, if you add up all of this planned offshore wind capacity that I just mentioned, you come to about 140 gigawatts, and that's at the very least, because I'm sure I forgot a few countries in my list. So that means we need at least 140 billion euros in order to build the grid infrastructure to connect those wind farms worldwide. That's 14 billion euros a year until 2030.
Okay, thank you, Keith. It was a very good overview. So in summary, there will be a huge offshore wind potential around the world in the coming 10 years. And this big investment volume you just mentioned will please the banks and all the financial institutions which can finance those projects, but also the consultants preparing those projects and the developers will be very pleased about those opportunities. Moving on with another question. What are the grid integration issues going forward? And I would like to raise this question more in the what direction. Yeah, we've got radial connection concepts in AC and DC technology. The first mesh solutions are realized. We have heard from Lawrence the example today. How would you characterize the issues? Are they more of regulatory, organizational, technical, or operational character? Can you elaborate on this with your experience, of course, from the promotion project?
Yeah. So, of course, there's not one answer to that. All the different aspects that you mentioned there are issues and challenges that we need to overcome in order to realize this and actually build something with all of this investment that we have to realize. So, from a technical perspective, there are several things that still need to be handled if we're going for an HVDC grid and multi-vendor interoperability, and how do you actually define how a multi-terminal HVDC grid, whether it's radial or meshed, should behave, and how you can integrate HVDC circuit breakers into such a grid. That still remains an issue, but that is something that is the industry is very aware of, and several initiatives have been set up now to handle that. What you can see is that from a planning perspective, in individual countries, especially in Europe, a lot of experience is being gained from the early days of offshore wind connection. Where at the beginning we most of the countries had a model where the offshore wind developer would build its transmission link to shore and also pay for it and operate it. Most of the European countries have moved to a model where there's one party, typically the TSO, that builds all of the offshore grid connections, which allows them to make a modular approach, to standardize, and to bring down costs from that perspective. And this has been shown to lead to lower total costs. And because of this experience, you see that also in the UK, which is one of the last countries where this they call it developer builds model still exists, is moving towards a coordinated approach like that. The next challenge will be, how do we move from those regional optimums to a more global optimum on a European level? So how do we align these different standardization approaches in the different European countries on a European level? And that will take probably a lot of political will. And you can see that the first small steps are, well, small, actually relatively big steps, I guess, are being made in that direction with the bilateral agreements between Denmark, Germany, and the Netherlands. But as I mentioned earlier, I think we should really try to make that one multilateral agreement. And that will take political will and political backing and a good explanation to the voters of why it is a good idea to go to such a multilateral approach.
Yes, we had actually a question in the chat, and you mentioned a lot of words with multi at the beginning. So multi-terminal, multi-vendor, multi-purpose, multi-actor.
Yeah.
So this question, if multi-terminal, multi-vendor, and multi-country models are the target, how does this interact in a world where these are sanctioned, leveraged against countries like Russia, for example, the recent discussion on the pipeline, and how easy is it for this model to work in a geopolitical world?
Yeah, I think it's a good question. I mean, in order to build this type of grid, there needs to be a level of trust between the participating countries, and not only between the participating countries, but maybe on a more general level between the participating stakeholders. And this will be strategically important and critical infrastructure. Do we trust other countries outside the European Union or outside the NATO, for example, enough to deliver equipment that will run into this system? You could foresee the same kind of discussion as was had around the 5G equipment of Huawei. I'm not the expert on that, but I do think that we need to be cautious, at least about verifying to the extent possible that this equipment cannot be tampered with by parties that might want to participate in this market from a maybe not so fair point of view. So to first build this system in a European setting where we work together towards a common goal with a common understanding of what our rights should be as citizens in this world in Europe. That should be the first target before we expand it to other countries outside the European Union.
Thank you, Cornelis. And I apologize that you put you in a little bit of challenge situation with this question, because political questions are always difficult to answer. Going more to the technical side again, there is also a question about the network code development and the RFG from European Union and ENTSO-E. Is this the sufficient step? Can we build on it? And my question is, what kind of other standardization needs do you see?
So this standard, it's not a sufficient step for the build out of offshore HVDC multi-terminal grids, but it is an important stepping stone because it describes the interface of the generators with the converters offshore on the AC side and how they should behave. And as such, it forms an input to the development of an offshore HVDC system grid code, because they should be compatible with one another, of course. And that's when we already answered the question, what should be the next step, what is missing? An offshore HVDC system grid code. Right now, there's no commonly accepted standard for how HVDC systems should behave in a functional way. This is underway. Many parties are working on this, but not yet from a formal perspective, as far as I know. So that should definitely be an important first step to start working on this, and to recognize also that, of course, this takes time, and that actually operational experience is needed in order to make the best type of the best HVDC system grid code. So it will evolve over time. On top of that, there are, of course, many standards for the individual components inside a meshed multi-terminal HVDC grid that still need to be developed. When you're talking about HVDC circuit breakers, how do you test these? HVDC gas-insulated systems. Working groups have just been set up in the IEC to make those standards, but they are not here yet, and it can take a long time before they are actually formally approved and in use. So that's definitely a process that needs to be sped up, if possible, for use in these grids.
Okay, Kees, thank you. There is a question from Chris in the chat, and this relates to the power transport or hydrogen energy transport. So how do you see the split between offshore AC/DC or hydrogen energy transport? Are there any studies available on this? And I could add to this question, did this play a role in the Promotion 1.0 project?
Yeah. So first of all, let's address the AC versus DC question. We did also look at that in a promotion project, because also in the future there will be wind farms closer to shore, which for which it's probably cheaper or at least more beneficial to connect them with AC. And in the promotion project, at least we concluded that those connections are most likely going to remain AC also in the future. So there's also always going to be a certain split between AC and DC. AC is not going to disappear. It will play and continue to play a major, maybe even growing role in the future. Having said that, the cost of DC is we think it will come down. The cost of converters, the cost of cables, hopefully as well over the future. So that will bring the break-even distance of AC and DC closer to shore, or with a smaller transmission distance. So from that respect, we believe that the share of DC in the power system will grow significantly. And this is also something that then here I'd like to refer to the DNV-GL energy transition outlook, where we model these kind of aspects. You can see that where DC now plays an almost insignificant role in the total transmission line capacity in the world. By 2050, we think 15 to 20%, I think, of the transmission line capacity will be in some form of DC. Then when it comes to the comparison between DC power transmission and hydrogen as an energy vector, we conveniently made the decision in promotion, at least, to not consider hydrogen, since it was not part of the original scope of the project. This is, of course, not the full picture, because naturally hydrogen will play some role in the energy future. As I already discussed earlier in the Q&A session, I personally don't believe that hydrogen production will play a very big role offshore on energy hubs. If it will be implemented, my feeling is that it will be more on the coastline, close to where the big hydrogen consumers might be, industry, close to where potential synergies could exist in using the waste heat of the hydrogen production for example, sector coupling, and where the infrastructure for producing the hydrogen can also be used with other energy sources other than offshore wind. So, for example, if you have a surplus of solar energy, you might also want to use that to produce hydrogen with that, and then it doesn't make sense to place this equipment offshore.
Yes.
I hope that answers the question. But about the ratio, I don't exactly know. I do know that there is a report made by DNV-GL for TenneT, which I think is publicly available on the internet, where the business case for hydrogen on offshore platforms or islands is further studied.
Mm-hmm. There's a question by Christian in the chat related to this discussion as well. About the energy hubs and sector coupling, the power to X question, and the projects now announced from Denmark and Germany, EnergyNet and 50 Hertz. So what is your view on this approach, and do you think in the long run of energy islands to be energy hubs or offshore meshed grids?
Yeah, so the energy islands, the concept of an energy island should not be confused with the concept of what topology of grid are we going to have in the future. Mm-hmm. So the way I see it is that the use of an offshore island is reducing the total cost of building an offshore grid connection system for certain offshore wind farms above a certain scale. So when you go above a certain number of gigawatts, it is simply cheaper to build an island as a support structure rather than a platform. And when you're building an island, it also opens up a lot of other opportunities, of course, that you could build accommodation, storage facilities, a harbor, an airport, all of those different things, which you might not be able to do so easily on a platform. And this makes sense when you're going very far offshore. Of course, then there's the question, what kind of electrical infrastructure are you going to build? And here we have the options between building many point-to-point links from the island, where you have an AC hub on the island, and then single HVDC point-to-point links to the different countries around the hub, and the offshore wind farm being connected to the AC hub on the island. Or you could build a DC hub, where you also have DC connections going out, but you only have converters between the DC hub and the offshore wind farms that are connecting to the island. Now, which one of those is most suitable is most likely dependent on the ratio of how much interconnection capacity does the island have. So how many gigawatts go to other countries around the island versus how much wind power is connected to it. Mm-hmm. If you have more interconnection capacity, it makes more sense to build a DC hub than if it's a pure offshore wind export linked to one country. Mm-hmm. And the reason for this is that the hub also in the interconnection case has to accommodate interconnection flows. So these are flows that go through the island rather than being injected in the island that the offshore wind farm does. And in the case of an AC hub, they would then have to go through two sets of converters. So you need more converters, you have more losses, more downtime also with more converters, more maintenance. Whereas in the DC hub, they would simply flow through the DC hub, and that would save a lot of cost.
Mm-hmm. Kees, a hub is of course a infrastructure which a relatively large power at one point concentrated. How do you assess from a reliability perspective the failure situation? Are we from a technology perspective able to manage those situations properly, or do we still need further technological developments, and where are they?
Yeah, so there are a couple of aspects related to that. So one is, of course, the stability in the hub itself. Do we know how to connect this many of this much conversion capacity onto one point? Converters from different vendors, converters that have no inertia in them and run a stable AC output, for example. This has not been proven yet, but there's a lot of research going into it, and I'm quite confident that this will not be a barrier to these hubs being implemented. A bigger problem is, of course, the single point of failure issue. So when you have a hub that 10 gigawatts of offshore wind is connected to, and for whatever reason, like a freak weather or an attack, you lose the hub. That means you lose 10 gigawatts of generation in the European grid. And that, I think, is really the biggest issue that we have. The maximum loss of in-feed levels that we have now are the size of offshore wind farms is beginning to approach this level or even exceed it. And then how do you connect this to the grid in such a way that you can still maintain a reliable network? And building more grid connections in which you have more redundant paths for the power to be routed in case you do have such a failure will increase that reliability. But of course, it will also increase the cost. So we will have to find a sort of risk-based compromise in that.
Okay. Kees, time is almost up of our expert session, but I would like to raise maybe as a final question, not the failure situation, but looking more to the opportunities related to cross-border offshore networks. Could you please briefly summarize again, where do you think are the opportunities in building those offshore grids?
Yeah, so if you look at the regions in the world where it seems likely that these type of grids will be built, so this is regions where you have relatively shallow seas, where you have energy centers around those shallow seas, and a good offshore wind resource. Of course, the North Sea is a very clear example of that. But also the coast off of the US, the East Coast, you currently see many plans for offshore wind farms. And the state regulators and energy departments thinking out aloud about what could an offshore grid do for them, and also an offshore grid that can go across state borders, which is not that much of a different situation of what we have in Europe. Of course, in the Mediterranean Sea, there are plans for cross-border multi-terminal grids like Eurasia. And as I mentioned, in Asia, there are a few steps towards cross-border HVDC grids, for example, between China and Korea, or even between Australia, Indonesia, and Singapore.
Okay. Thank you very much, Kees, for this kind of global outlook why we need offshore grids. Many thanks to all of you in the audience. We had approximately 90 participants in our Meet the Expert session. Cornelis, special thanks to you for taking the challenge of answering all the questions. I will not repeat everything what has been discussed, but my conclusion is, and this is for the whole energy industry valid, for the developers, the TSOs, the manufacturers, authorities, and advisors. We will have plenty of interesting work in the coming 10 years regarding the integration concepts. There might be technical issues related to the interoperability of HVDC and the integration aspect into the onshore systems. There might be the market impacting topics with less and less inertia in the onshore systems. And there might be regulatory issues, what to do in a failure situation with ever increasing wind farm sizes and the planned meshed solutions. With this, I would like to close this Meet the Expert session. Thank you very much for everybody, and I would like to invite you to follow on the conference. Thank you very much for today.
Thank you. Thank you, Gunnar.
Thank you.